Okay students, let's do one problem in case of the continuous mass distribution, or we call it as the continuous bodies. To do so, we are taking a rod, okay students, which has a length of L and got a mass of M. Okay, to find the center of mass, we are taking a strip which has a thickness of dx and mass of dm. Okay students, you have learned that position of the center of mass for continuous bodies is written as integration of derivative of mass into x by integration of derivative of mass. Okay, first we have to calculate this one. What is the derivative of mass? Derivative of mass is nothing but the total mass by total length multiplied with the thickness of strip or stretch what we took here. Then obviously it can be written as dm is equal to mass is m by L into dx. Okay students, here m by L is known as linear mass density students. Okay, and it is shown with the letter lambda. Then m by L can be replaced with lambda in the equation. Then the equation can be rewritten as xm is equal to integration of dm into x by m. Okay, by integrating the dm we will get the total mass. That's why I wrote in this way. Then it can be written as 1 by m integration of derivative of mass into x. Just replace derivative of mass with m by L. It is lambda, okay, dm is equal to lambda into dx, here lambda into dx into x. Okay, lambda is a constant, I am bringing it out, integration of x into dx. Okay students, we have to find out the center of mass with respect to this axis. Is origin and the top, whereas the other end is situated at L. That means the limits are 0 to L students. I am putting the limits as 0 to L. Okay students, and you know that integration of x to the power of n into dx is equal to x to the power of n plus 1 by n plus 1 plus c. Here we are integrating x, integration of x into dx is equal to x to the power of 1 plus 1, so 1 plus 1. It is x squared by 2. Now we are substituting this value with this relation. What we get? xm is equal to, okay, lambda by m, and we integrated, that is x squared by 2 and the limit 0 to L. Here xm can also be written as lambda. Obviously know that it's m by L upon m. I am bringing out the 2 x squared and the limits of 0 to L, where m cancels. It is 1 by 2L into L square minus 0. We put the upper limit as L and lower limit as 0. Then what we have? It is 1 by 2L into L square, L and square get cancelled. Get L by 2. Then location of the center of mass is L by 2. Okay students, it is the evidence for the center of mass of a body for a regular shaped one lies at the geometrical center. At the beginning we talk about that. If you need the further information, you can see the first video on center of mass. Okay students. Let's do one more problem on continuous mass distribution students. This time we took a thin rod which is bent like a semi-circle students. It is the rod, okay, and okay, obviously it is the radius students. we have to find out the center of mass of this system by using the integration method, students. Okay, you know that xcm is equal to integration of dm into x by integration of dm, and as well as ycm is equal to dm into x by y by integration of dm. Okay, students, if you watch it carefully, it is origin. That means what? Center of mass of the system along the x-axis is along this direction. That's why you can say the coordinate as 0. But what about what is that? Center of mass with respect to y-axis. Let's imagine a stretch is taken. Every time we are taking a stretch, okay, students, okay, the stretch has a length of ds and with the mass of dm. Okay, students, and see this, I'm connecting the stretch with the center of the circle. Look at this angle, we call it as the d theta, and is a theta which is making me this. Actually, it is very thin. Almost these two are coinciding with each other. If you watch it carefully, we will get an arc here as the theta. It is a radius, and obviously it is radius. Okay, students, from geometry, you learn that angle is equal to length of arc upon length of radius. Is the angle we are taking derivative of theta is equal to length of arc. I told you it is derivative of s by radius. Okay, students, then you can write ds is equal to r d theta. We related the radius, derivative of theta, and as well as the what's that length of the strip as ds is equal to r d theta. Okay, students, then after we have to find out the mass of this strip. Okay, as you learn that derivative of mass can be written as mass by length into dx. Okay, here we are taking dx as ds, then derivative of mass is equal to m by l into ds. But what is the length? In previous case, it is a rod, then automatically we took length as L only, but it is bent in the shape of a, what is that, semicircular arc, and you know that the circumference of the circle is 2 pi r. Then this length L is equal to 2 pi r by 2. Okay, it is equal to pi r. Then mass can be had as derivative of m. Okay, m by pi r into ds. Okay, where m by pi r is areal mass density. Sorry, m by pi r is the linear mass density. Okay, students, here this equation, derivative of mass, I am taking it as the lambda only, is equal to lambda into ds. We have the ds derivative of s, lambda into r into d theta. Derivative of mass is equal to lambda into r into d theta. Let's substitute in the equation ycm is equal to integration of derivative of mass into y by capital M. It is 1 by m into integration of derivative of mass. We had lambda into r d theta into y, okay, under the limits 0 to pi, students. We don't know the value of the y. Here we have to find out the value of the y. Y is the position of the strip along the y-axis. It is. Okay, students, now we are resolving this triangle into components. If this one hypotenuse is r, then it might be along the x-axis. Rx is equal to r cos theta, isn't it? And y component, ry is equal to r sin theta. Here, this y is the component of r along the y-axis. We can write y is equal to r sin theta. Okay, students. See, students, we got the value of the y is equal to r sin theta. Okay. Now we are substituting the values in. YCM is equal to lambda, I am bringing it back out. Okay. Lambda by m 0 to pi into r d theta into r sin theta. Okay, students, then it can be written as YCM is equal to lambda by m r squared. These are the constants under the limit 0 to pi into sin theta into d theta. Okay, students, as you know that integration of sin theta into d theta is equal to minus cos theta. Okay, then it can be written as lambda r square by m minus of under the limits cos theta 0 to pi, and you know that pi is equal to 180, that is cos 180 is equal to minus 1. Then it can be written as lambda r squared by, okay, cos theta. That means what? Cos 180 minus cos 0. We took the limits 0 to pi. Okay, students. First we have to put the upper limit. That's why we got it as lower limit is 0. Okay, it is minus pi r squared by m into cos 180 minus 1 cos 0. Okay, 1. It is lambda r squared by m into 2. That is 2 lambda r squared by m. Okay, students, further it can be written as YCM is equal to 2r squared by m, and we are substituting the value of the lambda. Lambda we have, it is m by pi into r. Mm get cancelled and r squared, that is 2 by 2r by pi. It is the method to find the center of mass of a circular, semicircular thin rod, students.